Good morning, everyone. Welcome to our webinar series number 2, the second part of the Food Safety and Home-based Beverage Processing. My name is Joanne Ico, and I'm with Diane Santia and Sir Jerickson Co, the Sales and Marketing Manager of KitPet Incorporated. For our participants for this morning, thank you po for joining us. After the presentation, you are allowed to ask questions po kay Ms. Olga. And hindi na po natin papatagalin, let's proceed to Ms. Olga's presentation. Hi, Ms. Olga.
Hello, good morning. I'm Olga Lazo, a practicing researcher on different food processing technologies from UP Diliman. And today we will be discussing food safety in home-based beverage processing, part 2. So last Wednesday, we talked about the main steps in juice production and mentioned the different processing methods for juice such as flash, pasteurization, in-pack pasteurization, cold filling, aseptic filling, and hot filling. We also spoke of the general practices in beverage processing, such as how to clean the packaging materials, particularly glass and plastic bottles, and in what temperatures do we need to store our finished products. We've also mentioned the temperature danger zone and some good manufacturing practices or GMP for personnel. So yung points of discussion is what is hot fill hold process, principle of hot filled hold process, yung behind each step, the advantages and disadvantages of hot fill hold process, and the reasons for spoilage. So the hot fill hold process, it's actually called hot filling sa iba. As the term suggests, it is filling the product hot, sealing the container, then holding filled containers for a period of time at or above a certain temperature before cooling. So by the term hot, we mean that this temperature is high enough to ensure pasteurization of the container and the closure or the lid. So there are actually four main steps involved in hot fill hold process. So the number one is pasteurization, second filling and capping, third holding, fourth is rapid cooling. So prior to the filling of the containers, we need first to pasteurize the product, which is usually done at temperatures 90 to 95 degrees Celsius for 15 to 20 seconds, depending on the type of the product. Second step is the filling and capping, wherein the product is filled into the container at 82 to 85 degrees, and the container is immediately capped and sealed. Third step is the inverting of the container, and the product is held at this condition for at least 2 minutes. And fourth is the rapid cooling, where as the name suggests, the product is rapidly cooled in cooling water via shower or water jets. So this is a general flow chart of how hot filling works. So the juice goes through the number one step, which is pasteurization. This one. Heating at 90 to 95 degrees Celsius and held for 15 to 30 seconds. Followed by the second step, which is filling and capping at 82 to 85 degrees. Followed by the third step, which is holding, wherein the container is inverted and held for 2 to 3 minutes. Followed by the rapid cooling, drying of container, and the labeling of the product. So, what are the principles behind each step? So, first, let's discuss pasteurization and on which products is it used for. Pasteurization is a mild heat treatment, usually at 100 degrees Celsius or below, and used for high acid or acidified foods. The high acid foods and acidified foods are those with pH level of less than 4.6. So why do we only use mild heat treatment for high acid foods? The reason is this. The low product pH will prevent bacterial spores from growing, such as that from Clostridium botulinum, in which upon ingestion can cause botulism and eventually death. These are the recommended pasteurization temperatures for food products with varying pH level. So foods with pH less than 3.5 should be pasteurized at temperatures at least 79.5. Those with pH 3.5 to 4, at least 85 degrees Celsius. Those with pH 4 to 4.3, at least 90 to 90.5 pasteurization temperatures, and pH 4.3 to 4.5, to 99 degrees Celsius. So as you can notice, the appropriate pasteurization temperature should depend on the pH quality of the food product. The pasteurization temperature should increase as the food becomes less acidic to ensure that bacterial spores present in the product would be destroyed. Examples of high acid or acidified foods include fruits, jams and jellies, fermented foods such as pickles. Here's a general figure or view of the pH value of several types of food. So pH actually ranges from 0 to 14. So a pH value of 7 is considered neutral. pH values less than 7 is considered acidic, while those greater than 7 are considered basic or alkaline. So during thermal processing, the borderline pH used by processors is 4.6, which separates high acid and low acid foods. So high acid foods are recommended to be pasteurized, while this portion of low acid foods usually or should undergo sterilization. Low acid foods include vegetables, meat products, baked goods, and egg whites. Now we've come across the term acidified foods. So these are the foods wherein the pH of low acid ingredients is lowered by the presence of acid, usually by the addition of, example, vinegar or lemon. So remember that producers of acidified foods must register their formula and processing similar to low acid canned foods, since any misstep in the production that reduces the ratio of acid to low acid ingredients could result to a food not sufficiently acidified, which could result to a deadly case of botulism. Examples of acidified foods include salsas, sauces, marinades, and some pickled vegetables. Second step, let's discuss the principle behind filling and capping. The principle behind filling and capping. So, the temperature is critical to ensure proper pasteurization of the product while filling into the container. So this is usually done at temperatures 82 to 85, well, depending on the type of your product. And, no. So the minimum temperature should be 82 degrees Celsius. So dapat 82 lang talaga siya, hindi siya bababa ng 82. It is actually a good practice to heat the food to 5 to 10 degrees Celsius po ito, above the recommended temperature before filling. So this allows time for filling and sealing. Now, if glass jars would be used, they should be preheated at 60 degrees Celsius prior to filling for the following reasons: to temper the glass and avoid breakage, and to avoid cooling the food excessively during hot filling. Now, if PET bottles would be used, we should ensure that the plastic bottles are thick enough to withstand high temperatures. Based on my research, the weight of PET bottles used in hot fill systems ranges from 20 to 28 grams as compared to the 16 grams PET bottles used in aseptic filling.
For PET, for our viewers, no, PET for hot fill is slightly heavier for a couple of reasons. One big part of that is yung structure natin. Kailangan natin lagyan ng paneling. Kailangan natin lagyan ng paneling like what you'll see here. That is for the vacuum that will be inevitable when your product from, say, 80 degrees gets cooled down to about 5 or 6, or well, actually, down to about 20. The paneling needs more weight. So ngayon, mas mahal ng konti yung mga, kung compare natin ang bote ng tubig na PET versus bote ng hot fill na PET. It's also a different material when it comes to PET. May iba-ibang tinatawag natin na melt index or MI. Iba yung viscosity ng produkto, mas may kapal ng konti yung PET. It translates to roughly the same in terms of raw material price, pero dahil, say, ang PET na hot fill, kailangan natin ng 27 grams for, say, 350 ml. Ang regular na tubig na 350 ml, kung makakakita kayo ng may mga 9 grams na nga. So may ganong penalty tayo dahil lang mainit yung i-fill natin. Hindi naman sinasabing penalty, pero may ganung dagdag tayo na cost because of it. Yeah, but I think it's still, well, it's still depende na rin, could depend on what you would want to use. Glass is sometimes a little bit heavier for that matter, or mas mahal ng konti for that matter.
So, another important factor during filling and capping is the headspace of the product. So, the headspace, as the name suggests, is the unfilled space between the lip of the container and the surface of the food. So, this allows room for product expansion during processing. Headspace should be appropriately followed to protect the quality and safety of the product. So, ito po. Too much headspace may cause darkening of the product during storage due to the excess air or oxygen and reduced vacuum level. On the other hand, too little headspace can cause the food to bubble out, which can leave deposit in the rim of the container and may prevent the container from sealing properly. So here's the appropriate headspace for different food products. So the headspace for jams and jellies should be 1/4 inch. For fruits and pickles and tomatoes, 1/2 inch. 1 inch for vegetables. 1 inch for meat, seafood, soups, and pie fillings. And 1 and 1/4 inch for poultry products. Now let's discuss the principle behind the third step, which is the holding. Holding the product and inverting the container at temperatures 82 to 85 degrees Celsius for at least 2 minutes actually sterilizes the inner surfaces of the container and closure. By closure, we mean the lid. So, to destroy any microorganisms present in these surfaces. So, the fourth step, which is the rapid cooling, this is the principle behind it. Rapid cooling of the product actually creates an internal vacuum, as mentioned by Sir kanina po, within the container due to the shrinkage of the beverage coupled with condensation of the water vapor in the headspace. Rapid cooling is done first to provide an anaerobic, meaning ng anaerobic is without oxygen, unfavorable for aerobic microbial growth. And second, to reduce the oxidative degradation of vitamin C, which is associated with flavor changes and discoloration during storage. Always remember that the tightness of the closure or lid is very crucial to maintain the vacuum and avoid post-contamination of the product. So the third reason or the third principle behind the rapid cooling is the rapid cooling ensures the product and vitamin integrity as extended heat exposure can affect color and vitamin content of the product. So rapid cooling is usually done using 50 ppm chlorinated cooling water by means of shower or water jets in a cooling tunnel as shown in this photo. Now let's discuss advantages of using the hot fill hold process. Through the hot fill process, interior surfaces of the packaging is sterilized, which in turn prevents growth of microorganisms inside the package and thus enhances the shelf life of the product. Other processors used to label their products as natural since beverages processed using hot fill do not need to use preservatives, and the keeping quality of the product solely depends or relies on the destruction of microorganisms during pasteurization followed by hot filling. And it has actually a less complicated process and filling line than aseptic filling. So the disadvantages of using the hot fill hold process include the following. So the product can withstand the high temperatures brought about by the pasteurization followed by hot filling. Also, hot filling cannot be used for carbonated products due to the excessive amount of foam created when introducing carbon dioxide to a hot product. So hot fill systems require large floor space. And last but not the least, since hot fill PET bottles are thicker than usual bottles used for aseptic, these bottles are often expensive, as mentioned by Sir nga kanina. So what happens if the food product was not thoroughly processed or the right pasteurization and hot fill process was not followed? So spoilage of the product may occur. The type of spoilage most encountered in high acid foods is yeast or mold. Manifestations of spoilage include the following: visible mold growth on top of the food, such as this one, cloudy liquid, production of carbon dioxide, which is caused by yeast contamination, container swelling due to fermentation, of odors, and changes in color. So any containers with visible or suspected spoilage should be discarded. So what are the reasons for spoilage of these products? In a research by Tornas et al., the reasons for spoilage of fruit juices and fruit salad by yeasts and molds include the following. So usually processors use low quality fruit or raw material, meaning the raw materials used for production are heavily contaminated and partially spoiled. So there's also lack of adherence to GMP during preparation and transportation. There's also abuse of storage temperatures, particularly at the temperature danger zone. So this will increase the numbers of contaminating yeast and molds, since these organisms grow at much higher rates at temperatures above refrigeration, most especially if the packaging material or closure is compromised or not intact. Another reason is the inadequate pasteurization and post-pasteurization contamination during cooling, bottling, and storage. So during preparation and processing, additional contamination can originate in unclean kitchen utensils, packaging, and other materials that come in contact with the food. So the product must be adequately pasteurized, and correct hot filling procedures must be strictly followed. So that's all. Thank you.
Thank you, Ms. Olga, for the presentation for this morning. For our participants, the question and answer session is now open. If you want to ask question, please raise your hands. Anyone? Sir Ray, ikaw, baka may questions po kayo.
Ma'am, thank you very much for the informative document and nice presentation.
Thank you
Kumusta
po.
po sa lahat? My question is about our processing about pineapple juice. Dun sa amin kasi po, nakita ko dun sa kinabibilangan niya is 4.6 pH yung kinabibilangan niyang pH. So, nakalagay po doon is 79.5 degrees centigrade. Dapat siya piniinit. No? So, nagre-range yun sa amin ay 80 to 85. Fluctuate yun sa aming lutuan. So, sa double jacketed kettle. So, pag nagre-range siya ng 85, bumababa, then may cooling down. Ngayon po, ang nakikita namin, usually ang nangyayari ay yung discoloration. Dahil nga sa yung label namin ay medyo nakalantad pa sa sunlight. So, ganun lagi yung aming problema. After 2 months, may discoloration na siya. O kaya after 2 weeks, may discoloration na yung produkto namin. Kaya kung yung iba't ibang araw ng batches ng process, pag pinagdikit-dikit, parang nag-iiba-iba yung kulay. So, yun ang unti-unti namin ina-address sa produkto namin. At ang tanong po dito ay gusto namin i-prove kung ito po ba ay may kaugnayan doon sa raw material level and then yung outside exposure sa sunlight, yung pagkakaroon ng discoloration.
Ako masasagot ko yan. Pero Olga, go ahead.
Yun po, kasi ang possible source niya is, di ba nga po, marami ng microorganisms to begin with. Marami po doon sa raw materials, ganyan. So, tas during processing, until storage na. So, dapat po, linisin muna or dapat fresh yung ingredients. dapat walang expired, walang may kita kayo, meron mga molds, wag niyo isasama, ganyan. Posible kasing doon po manggaling yung yeast. Kasi sabi niyo po, 'di ba, medyo nagdi-discolor. Pwedeng 'yon, pwedeng sa yeast or pwede pong nag-degrade na din yung vitamin C na nandun sa product. So, ano yun, sir?
Bingo.
So,
That is the
vitamin-
exact answer.
So, vitamin C na nandun sa product, pwedeng depende, ano ba? Pwedeng may mali po sa headspace. Pina-follow niyo po ba yung headspace? Pwede po doon. Tapos, dapat kasi correct po yung way, no, yung vacuum po niya, ganun.
Okay, sige. Sir, sagutin ko lang muna yung tanong nyo. Nagkukulay, di ba, pag natatamaan ng araw? UV po yun.
Kunin ko po yung isang example po. Ito may bote po.
Sige.
Ganito po siya.
Yeah. That's 2 weeks.
Iba. Pero yung lasa po niya, okay pa naman yung lasa. Yung
tama.
kulay nga lang.
Tama. Tawag po dyan UV degradation. Ibig sabihin, hindi naman po nag-bloat yung bote, di ba? Hindi naman siya parang nag-ferment. Okay. That's still a liquid na pwedeng inumin. Yung problema natin, sunlight affects vitamin C or sunlight affects UV. Ito po yung isang example. Ito po yung isang example. Mayonnaise po to. May konting acidity sa mayonnaise kasi may konting lemon juice. Nagpapalit talaga ng kulay. With clear glass or with PET, that'll affect it. Okay. Depende na ngayon on how you want to address the problem. Pwede po, may mga companies na nagdadagdag ng citric acid sa produkto nila. Yung ascorbic acid na dinidikdik or citric acid na dinidikdik. Yeah. Para yun muna yung magpapalit ng kulay. Ngayon, that might affect yung flavor po ng produkto. Depende po yan sa length na hinahabol natin.
Citric pa ba is
Another direction is to actually just remove to actually just keep it from sunlight. May mga solution naman na buong shrink sleeve nila binabalot yung produkto tapos nilalagyan ng UV blocker. May ganun na options po pagdating sa PET, may konting kamahalan ng konti. Nagdadagdag siguro mga 1-2 piso no, pagdating sa UV blocker. Pag hindi palitan yung mga bote. Pag hindi palitan yung dagdag na UV, yung formulation ng product. Pero any product, even alcohol, if you leave it out, or olive oil, if you leave it out, it's pretty much a sunlight problem. Ayun. Pwedeng dagdagan ng citric is one solution, or just keep it away from sunlight is another solution. Pero hindi naiiwasan yon whether it's a glass or a plastic bottle.
Thank you very much.
So may mga tao, buong sleeve na lang sila ginagawa. So yung labeling cost, I know there are shrink sleeves that can protect yung buong produkto. Tapos may maliit lang na butas para makita. That gets you to mga tawag po doon. That gets you to mga an extra peso for your labeling. Kaysa sa, let's say, yung mga ganito pong klase, isang buong shrink sleeve po yan. May makina, papadala sa tunnel, biglang nagsishrink. Ayun po, mga piso isa po yung nagiging label nun. Pero malakihan yung order. Ganun.
Next.
Sige, sir, go.
Pwede po. Ito po ba sa amin, yung tungkol dun sa filling and capping? Ang headspace po nito ay 1 inch po ba? O tama po ba itong headspace namin?
Mukhang sobrang puno siya.
Opo, actually. Medyo puno siya. Kung titignan niyo po yung mga yung mga commercial, kunyari C2, ganyan, or mga Minute Maid, may kita niyo po doon yung opo. Yes po.
Yes, thank you very much.
So, sir,
siguro na-take note ng aming food tech at saka ni Mr. Jan.
So sir, dadagdag ko lang po, ang dinedesign namin yung mga bote namin sa PhilPep na hanggang mga dito po, yung, let's say ito, 1 liter po yung hawak ko. Hanggang dito yung 1 liter, hindi dito. Kasi nakaplano yan na may headspace talaga dapat yung produkto. Yung kapag dito lang natin finifill, or actually hindi nga tatama dapat dito po sa doon sa simula na nung sa shoulder na nung bote hanggang sa takip hanggang sa shoulder lang talaga dapat tayo.
So, pwede na din, sir, kami na mag-sample, sir, yung 1 liter na yan.
Pwede. Pero, well, mahirap sabihin yan ngayon kasi sobrang dami ng order namin. So, hindi ko lang alam kailan ko mapoprovide. Pero,
3-5 piraso.
Mas madali sa akin magbigay ng 10,000 kaysa sa 3 piraso, to be honest.
Ganun ba yun, sir? Okay lang, sir.
So, nandun lang. Ayun. Pero sample natin soon enough. May tinatayo kaming bagong planta para ma-fulfill lahat ng mga orders. Dumami lang talaga yung rumagasa lang talaga yung orders because of the virus. Okay.
Kasi binabalak namin po mag-try nung 1 liter eh.
Yeah.
So, ang ano lang namin ay, yun po yung unang pinag-usapan din namin ni Ma'am Joanne nung pumunta sila dito. Bumisita sila dito sa amin. So, parang gusto namin i-try yung 1 liter.
Sige. Okay.
Okay. May questions pa kayo, Sir Ray?
Siguro po yung kasama ko, baka pwede si food tech namin, baka may gusto siya maano.
Okay. Si Miss Princess. O kaya si Sir Jan.
Nasagot na po ng mga tanong ni Sir Ray.
Ayun. Sagot na daw yung tanong. Okay. Kasi merong chat si Miss Faye Mariano. Baka pwede nating daanan ulit yung slides mo, Miss Olga. Ang tanong niya kasi is, what is the appropriate headspace for fruit juices? Ayun. Kalamansi daw. Yes daw.
Okay yan. Kasi sobrang high acid naman yung kalamansi.
Sorry. So yung headspace po na tinatanong niya is for calamansi juice, right?
Yes, ma'am.
Okay po. So, itong headspace niya is similar din with juice. Gaya po nung sinabi ni Sir kanina na dapat nasa shoulder siya ng bote. Ng bottle. So, ito po, usually, sa mga jars po ito. Tapos, yeah, sa mga jars po yan. And glass bottles. Though, sinabi nga po ni Sir Jeric po kanina na ano ba yun? Naka-design na yung bote for such volume ng product tapos may headspace na po dun. So, ganun. Nasagot po ba, ma'am?
Nasagot po ba, Miss Faye? May question pa siya, Miss Olga. Similar lang din daw ba yung concentrate and laman ng bottle?
Yes po.
Wait, I have an answer there. Sobrang
Sige, sir.
hindi.
Hindi ba,
Okay.
sir? Nakikita ko kasi sa... Anyway, sige po. Sige po.
I think in a food safety standard, yes, it technically is the same. Kasi you're just increasing the liquid but the pH doesn't change, or pH doesn't change that dramatically kasi logarithmic ang pH. Pero in a bottle standpoint, in a physics standpoint, ang concentrate mas maraming init kasi malapot siya. Versus liquid, halimbawa, babad mo yung kamay mo sa kumukulong tubig, masakit. Babad mo yung kamay mo sa kumukulo or 100 degree na say malapot na sabaw, mas masakit. So because there's more energy. So when you say similar dun sa laman ng bote, we have to test pa kung gaano kalakas dapat yung bote na gagawin natin kapag concentrate tapos versus hindi. So far, we've been okay. So yan ang masasabi ko. So far, we've been okay. Pero yung mga bote namin, dinesign namin sa juice. Alam ko, Joanne, may mga concentrate tayong customers, correct?
Yes, meron. Pero
Okay.
hindi sa hot fill bottle.
Hindi sa hot fill bottle. They do it on okay. And to be honest, concentrate has a lot of sugar and it's almost like a pickled product na medyo nabubuhay siya, but it's still not ideal. We have to try pa kung hot fill pwede on such a viscous product because there's a lot of energy na ipapasok mo sa isang bote that might not be as that might not perform as nice. We do design these for beverage and not for concentrate. Ngayon, we could always come up with a concentrate line with a far heavier, far thicker bottle. Pero, yeah, uunahin natin muna yung sa beverages. We'll get to that point.
Okay. Ms. Faye, may questions pa po sila? Okay. I think this is the end of our webinar. For more questions, please email us at marketing.philpetinc@gmail.com. See you po on our next webinar. Thank you and stay safe, everyone.